Sometimes you have some new code and some new tests, but you didn't write the test first. And now you have to answer the age-old question, should I even trust these tests? In this video, I'm going to show you two different workflows you can use when you didn't write the test first, but probably should have. So let's go. In our first scenario, we're working with uncommitted changes. So if we look at our status, we have some test code and then we have our actual application code. What we want to do is now run this test code without this application change. So what we can do is we can do git add test. We can do git stash with a keep index flag, and this will stash our changes, but also keep what we have staged. And you can see that's exactly what happened here. And now we can run our test. And if our test actually works how we think it should, this should fail. So we actually want to see the failing test here. So this is now simulating that we're writing the test first without actually making our code changes. Now, when we do git stash pop to bring that back, we are going to have our library changes back. And if we run our test command again, our test now passes. So even though our test was written after the fact, we can still make sure to quickly check that indeed the test will fail without our changes and the test will pass with it. And from here, we can commit it as normal. So what does this look like when your test doesn't work as expected? We're in the same scenario here. We're going to add our test. We're going to stash with keep index. So now we just have our test. And if our test doesn't work as expected, it will still pass here. And at this point, we're going to stop for a second. We're going to look at our test. We're going to figure out what went wrong, and we're going to get that red test before we bring our library changes back. So here we want our little add function to max out at 10. We have a test here that makes sure that the result of this function is less than or equal to 10, but adding 5 and 4 is never going to be greater than 10 anyway. So we're going to bump this up to 6. We're going to run our test again. We've got our failing test. Now we can pop our changes back from our test. And now we've got our passing test. In this next scenario, we're working with some changes that have already been committed. This could be something that you committed, or it could be changes coming from someone else. I personally do this all the time for code review. We can look and we see that we have some new test and some code change. What we want to do is we want to make sure that this test actually catches this bug that this code change is supposed to fix. So we look at our status, everything's clean. What we're going to do is we're going to check out the branch that this change was based off of, in this case, master. We're going to check out from this branch here the actual tests. And you can see here now we're back in the same scenario we were before, where we have our test changes without the code changes. And if this test catches the bug, when we run this, it will fail. So we have our red test. So here we can see that this test actually does catch the bug we think it does, and that means we can actually trust our code changes because they've now made this test pass. Now, it should go without saying, but this is no replacement for TDD. There's a bunch of other benefits you get when doing actual test-driven development, but sometimes you're in a scenario where you've already got the code, you've already got the test, and now you just need to make sure your test works. Peace.